Let's do this. How do I view it? Get help? No, thank you. Layout. Dashboard. Okay, I've got a dashboard. This is wonderful. Oh, I've got some alerts here. So we've got Thrillbot55 has followed. Thriller Gaming. Oh, I remember Sasquatch. He was having fun yesterday. Notifications. Yeah, okay. It's hiding at the top that isn't showing. Alright, this is messed up. This is totally messed up. Okay, that's better. Yeah, okay. That's fine. Today Thursday, yeah, thank you. Alert box widgets, yeah, where's chat? Where is chat? Let's see if we can find it over here. Might be easier just to go to YouTube and find it. Okay. Chat. Hello to all. There we go. No, that didn't work. Okay, let's try this one. Hello to all. Yay, that worked. Right, we've got chat. Yay. Oh, the beauty of it all. Lovely, I can see chat now. Let's take an exit on here. And this, by the way, is what we've got so far on our game. This is our game so far, I suppose. And we're just doing the graphics for the game. So that exit button should work, and it did. Yay! Don't want to be looking at you. So, as I promised on Tuesday, I said we were going to do the shaders. So, today we're going to do the shaders. Get to the shaders. So, Fong color. That's the vert frag I want. Texture vert, texture frag. So let's start with that one and work our way through. This is going to be slightly different. Yeah, we can do that. What the heck? Why not? We'll start at the top. We'll start at the top. I don't think this really matters how I do it. No, it doesn't really matter. So, layout. The first thing we're going to, well, what we're going to be doing is we're going to be doing the Fong lighting for our models. And that's a specific piece of code. And it's a model, a lighting model, used more often than not as a basic lighting facility for OpenGL and 3D and anything really. So what it's going to need is a normals. We haven't spoken too much about the normals. I've just included them everywhere, and well, now we're going to add them. So equals 2 in. We've only got put 3 in, haven't we? Yeah. Vec3 normal. Or normal, yeah, normal, I'll do. Position, color, and normal. Normal is the perpendicular to the face, so at right angles to whichever face we are drawing. and we use that to bounce the light, each individual ray of light from the source. We're going to call it the sun, I suppose, or whatever you want to call it. We'll see how it goes. But now we're going to need a few different things here, because we're going to need to use that normal, and we're also going to have to split down this mat 4 into a model, view and projection, the MVP. I want it in the individual bits now. So I'm going to call this one model, obviously. So you can see already that we've got quite a lot more coming into this shader. You're thinking, well, why do you want to split this down? Doesn't that make it more inefficient? Nope, it makes it more efficient, funnily enough. I'll tell you why in a second. So, model, starting with, yeah, we'll put capitals on it. Model, view, uniform, mat 4, and this one's going to be underscore model view projection. Okay. Remember, it's case sensitive when doing GLSL, the graphics library shader language. Oh, that coffee's lovely. I've just had a new delivery of coffee today. Oh, I'm going to enjoy this. Okay. We are also going to need another uniform. And this is going to be a VEC3. Yeah, that's all we need really, isn't it? Yeah. Uniform underscore light position. So we need to know where the sun is, or the lamp, or the light. We'll do multiple lighting some of the time, I think, but for now we'll just have a single light position. I think that's fair enough, isn't it? Right. I'm going to need a couple of consts. Yeah, we'll have a couple of consts as well. So I'll keep these separate. Const, float, density. I'll talk about these separately after as well. Density equals, I'm going to start mine off at 0.007f. These numbers are interesting because that's going to be the density of distant hazing, surface hazing, or can even be fog, full fog. So if it's going to be full fog, we'll need a gradient as well. We'll need to know the distance, how thick the fog becomes, like a gradient. If you've ever done a gradient fill of colours, you'll know what I mean, changing one colour to another. Well, this is a gradient of how much fog there is. So we'll have a const for that. I'll make it a float. And it can be just gradient, I suppose. These are numbers you can play with to make various different types of fog. Thick to very mild. 1.5 F. I think that's in meters. So every 1.5 meters, the fog density will increase. Think of it like that. Yeah. When it gets to 1, you can't see anything. You got the fog wall at 1 for density. So it's a percentage, so that's 0.7%, isn't it? Below it to 0.5. Fiddling around with those numbers gets you a good measure. We'll play with it. We will play with that. Now, going out of here, to our fragment shader, we are going to have to send a lot more information now. What we are going to send out is the color, obviously, because this is the color shader. We are going to send out a vec3, and that will be, I put a V in front of these, don't I? I'm going to make that a capital C as well now. Yeah, I'm happier with that. V underscore. I'm rewriting all of this, aren't I? So we're going to need a surface normal. So that's, oh dear, that's not going to work. V underscore. You don't have to have V underscore, by the way. You don't need to use U underscore, by the way. It's just the way I do it to remind me what the heck they are. So going out of the vertex shader, I put V underscore to remind me that it's coming from the vertex shader. As you will see in a minute or two, when we get to the Phong color frag, it's sometimes hard to know where variables are coming from. So that's why I do it. It's so that I can track the damn things. If anything goes wrong. As if anything would go wrong, huh? There's no chance of that. This is Blaze we're talking about. Let's have a surface normal anyway. Oh, that would be funny, wouldn't it? Things going wrong. Let's have an out. See how much more complicated we're going to have. So, vec3 again. So if we have the surface normal, which is 90 degrees to the surface, we can also calculate a vector. So a vec3, yeah, that's all we need. So it's going to be V underscore to the light. So the light vector from that surface. And you're thinking, but why are you doing all of this in the vertex shader? I'll come to that as well. It will all be explained, I hope. What else do we need? So if we've got the light vector, we'll need the camera vector, won't we? And that isn't a light vector, that's two light vector. And then we can have out. So from the surface normal to the light, we'll need another one to the camera, to camera. Ooh, vector. Yeah, that's okay. Do we need any more? Oh yeah, we're doing fog. Out. Yeah, helps. Float. We'll call it visibility. Does that look good? Yeah, that does. Now, let's talk about this a little bit. First of all, why am I splitting down model view projection, and why is it quicker if I do so? It is faster to calculate matrix multiplication and calculation in the vertex shader than it is anywhere else on your computer. The vertex shader is designed for it, and so is the fragment shader. Your whole graphics card is designed to handle this kind of calculation. Your CPU is not. So doing the calculation on the CPU of multiplying these three together is slower, ironically. But here we're going to be doing it for each vertex, and on the CPU, I think we were doing it per vertex. No, we were doing it per model, weren't we? So is it still faster? Yes, it is, funnily enough. But anyway, that's beside the point. Why are we also choosing to do all of these calculations in the vertex shader and not the fragment shader? And that's because the fragment shader, for each surface or each face, is going to run 3 times, whereas the vertex shader runs 3 times for each face. 3 positions equals a 1 triangle. That's a face. That's going to run 3 times through this, and the fragment shader is going to run possibly a few thousand times. Yeah, so I think I want to do as much calculation in the vertex shader as I can. There are things that I am not going to calculate in the vertex shader, which is the actual shading value for the pixel that lands on the screen. The reason for that is the fragment shader does it per fragment to see whether it becomes a pixel or not. A fragment is a pixel that hasn't made it to the screen. A pixel is a fragment that has made it to the screen. Oh, it's stupid language. So on the fragment shader, I want it per pixel lighting. If I put the final lighting calculation into the vertex shader, the final lighting will be per vertex instead of per pixel. And I want the granularity of pixel shading because it's gorgeous. Is it slower? Yeah. You can go for all the calculations in the vertex shader if you wish. Your choice. I wouldn't if I were you, because this is very fast anyway. Right, what have we got now? What we're going to do is... a few calculations, I guess. Swap windows. Right, I can see chat better now. It's a bit off because everything's in the wrong place. Okay, everything's in the wrong place and I'm not happy with where it is. Right, so the V color equals color. Is that still the same? Well, yeah. The color's not going to change. But everything else is. We're going to do a few calculations now. The first calculation, what should we do? We'll do a vec3. And we're going to call it world position. Model view projection. So when you place the model into the world, we want to know its position. Obviously, we need to know its position so that we can do the lighting. So, world position. We'll have world position. And that's going to be a simple calculation, which is a vec3, of course. Brackets. And all we're going to do is use the matrix, the model matrix, here. So we've got our model matrix, yeah. And we're just going to multiply that by the position vector and produce a vec3. That has to be a vec4. And that's position, comma, 1.0f. Yeah, that'll work. Because positions, we're still using vec3s, aren't we? Shall we change that? Yeah. We bring in that last number, the, what do we call it? Not visibility, it's translucency, whether you can see through it or not. The fourth number, 100% means it's a fully solid, and you can reduce it down to like 5%. You would hardly see any color. You'd be looking straight through it. It would be tinted glass, effectively. If we bring it in as a vec4, we don't need to do this kind of rubbish here or here. and it just makes the calculation a bit more sane. It works in our favour, so we now get control over whether the colour. Sorry, that's a complete and utter lie. Position doesn't matter what the last one is. It's colour that matters. Sorry, my bad. We are doing colour vec4. Oh, I'm not using it. That's clever of me. The fourth part of position we can ignore anyway is the homogeneous coordinate, the point in space around which you can rotate. The world, in fact, yes. So look up homogeneous coordinate. Have fun with it. If you don't understand it, come back to me, ask me to explain it, and I will. It's just a long explanation. I wasn't really thinking about doing that today. I just wanted to get these shaders right. So if I've got the world position, then we can make a delta camera. Yeah, we can. We can have a vec4 for that. Delta. I'm going to call it delta camera. And what we're going to use for that is the view matrix. Now you know why I wanted to split them all down. So underscore view. Yep. So I'm going to use the view matrix now. And we put the world matrix, world position to a vec3. Why not a vec4? There's a reason for it. Why am I using world positions? One second. To do with our light. Yeah. Okay, light vector is a vec3, so that's why I need it as a vec3. Okay. Fair enough. Delta camera is the view multiplied by, we'll change it to a vec4 because you can't do this calculation in vec3. So it's world position. This is the best way I think I can really do it. See, we're altering the size of the vectors all the way around, but this one's a 1.0 and it has to be a 1.0f for the homogeneous, so I'm fine with that. So, well, wherever the model is in the world, multiplied by the position of the cameras, the matrix for the camera, i.e. the view. Remember, projection only covers like field of view, how far you can see away from yourself. That's like the lens. Well, u underscore view is where the camera is looking from. So from the world position, you get a delta camera. So that is a vec4 of where the camera is away from the object. Broadly speaking, I'm trying to do this as simple as possible for you. So I'm going to call this GL position. Yeah, we've already got a GL position here. And we have done... Right, we'll skip you, mate. You're out of here. We'll come to the colour in a minute. So this is going to be our GL. This is going to set our GL position for a minute or two. Yikes! Can't type. Position equals, and this is the position of the. Well, this is the calculated position from all of this lot here. I need the projection, do I? Yes, I do. Projection is the last part of it, so u underscore projection. And we multiply that by delta camera, of course. So all I've done is MVP. So model view projection, the multiplications. But I've done them as a sequence so that I get the world position and the delta camera. This is why I needed to split it down and couldn't just have MVP. I wanted a world position and the camera position. Also, of course, we still have to tell the shader to send on the GL position for the screen. So the fragment goes to the right place. Right, V color, gonna leave alone. Now we'll do the lighting. So this next section does lighting. This is where we can use world position, delta camera and stuff like that. This is where we're going to get our V surface normal. So we can calculate that and send it on its merry way. That is going to be the result of a Vec3. And it's going to be... it's your model matrix. So that's the model matrix. And that all we do to get that is to multiply it by the Vec4. Has to be a Vec4 because it's a model matrix, is a 4x4 matrix. So we have to use a Vec4 for this calculation. And it's just a normal. Comma. This one's 0.0f. It doesn't have a homogeneous position. Don't think it'd work with a homogeneous position. Interesting. That's something to test out. Never thought about it until right now when I typed it. Okay. We want the next one is the 2 light vector. V underscore 2 light vector equals. And that's the underscore light position, which we have sent in, the sun or whatever, the light, its actual position. And that's minus, position. It looks a bit better, doesn't it, when I spell it right? I hope I haven't got any spelling errors in here. It doesn't seem to be highlighting much. It seems to be highlighting nothing at all. Wonderful. So I don't know if any of this is right. Light position minus world position, which is why I needed that bit. There we go. Is this not even coming up with... Not even coming up with IntelliSense? No, it's not, is it? Thanks, Microsoft. You are wonderful. GLSL. Your change will be scheduled. The modifications will begin when all Microsoft Visual Studio windows are closed. We have an interrupt to a normal procedure. We've got to most of our way through, but yes, please. I just realised we don't have GLSL. Language integration. Let's modify it. I forgot it's it's separate. God knows why. It's a goddamn separate mod. Oh, well, gives us a break, doesn't it? Usually I do all this offline, off screen. But at least you got to see me do something. Like go, oh, we have no integration. Thought it looked a bit dodgy. It's doing well, it's modifying. If it's there, use it. Let's see if that's made any difference. Oh, that's made an awful lot of difference. And it shows me there's an error. And I knew I had an error, I just didn't know where it was. Clever, huh? Clever. And the problem with shaders is it's very hard to spot errors. But errors you will have, like that there, not being a capital C. There we go. You happy now? Are you happy now? Are you happy now? Colour is VEC4. V colour is a VEC4. Why are you not happy? And there's one there, Delta camera. Semicolon. Thank you. And I've lost my lighter. So just bear with me a second. Awesome. Awesome sauce. Let's finish this coffee off and let's get this finished. So that's looking a lot better. We've got colorization and everything. There's white on black. Right, was after 2 light, 2 camera vector. There we go. Autocomplete is now working, so we'll make a vec3 out of... Oh god, here we go. We do not want the camera to the object. We want the object to the camera. We want the inverse. Inverse is available to us as it's on the graphics card. The graphics card gives us that command. And it's u underscore view. So we want the inverse of the view because we don't want it from camera to object. Okay. And we're going to have to multiply that by a vec4. And what can that vec4 be of all things? It has to be the centre of the universe. Only one centre of the universe in OpenGL. That's 0.0f. 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 And homogeneous coordinate 1.0f. How's that for a great calculation? It doesn't like it. So view, camera, two camera that's a capital T. That's a capital T. That's okay. What's wrong with that? Unexpected semicolon. Really? Could be. Is you right? From that, we do have to do a little bit more than that. We have to remove the world position to make it work. Alright, that'll do it. So how would I split that down so it made sense? So if we tap, oh, gone on. No. Tab once. Multiplied by that. And then just bring that depth back in. Yeah, we can put the multiply there, can't we? Inverse of that. Goes to there, that goes to there. That's right. And that goes to there. Lovely. Matching brackets. Should match with that bracket. Yeah, matching brackets, and yeah. So it's multiplied by the centre of the universe minus the world position. Yes, that's correct. And that will give us a vector from the model in its world position to the camera. You've got an inverse in. Right, that was a great one. And that's all we need, is it? Just need V visibility next. Right, let's do that as a separate piece then, here. So you can see we're doing a lot more calculations now. As many as we can. I'm just going to call this fog. I don't know what else to call it. What happened in OpenGL 1 is that fog was a command. In OpenGL 3 Plus, fog works in OpenGL 3. In OpenGL 3.3, I don't think it does anymore. I'm not certain. So we're going to do our own. It's exactly the same calculation as what it is in OpenGL, so I mean it's just their calculation. We're just going to stick it in here. So, float. We are going to have a distance to camera, because that's what it. We're going to do a gradient fill of fog in 3D. So this, how far away from the camera something is, will equal more fog. Yeah, there you go. Equals. I think length is given to us. Yes, it is. It's a graphics card one. So we'll take the Delta camera, which we need. And we'll only need the length of X, Y, Z. There we go. That'll do. We're allowed to do that, aren't we? Yeah, of course we are. A little bit of 3D trigonometry for you there. If anybody wants to do that in longhand, they can do, but I'll just use the length command, it's easier. So, as you just found out, GLSL has commands. Just like C, in fact. Funny, really, because I think you'll find on your graphics card it's written in C, or was written in C. And that's probably why it looks like that. V underscore visibility, yay. We get to it, and this, we're going to need an exponential here, because I want an exponential curve. So the further away it gets, the more and more fog there is as an exponential curve. We'll need a power. Let's see, distance to camera. Distance to camera times density. Of course, that makes sense. And we will make that to the power of the gradient. We'll use the gradient there. That's a lovely load of brackets. Alright. The only problem is that to the power of can go way, way up. So we'll have to clamp it down. So visibility equals, and let's clamp that. Clamp is given to us again. V visibility, comma. It's the lowest it can be is 0, obviously, no fog, and the highest it can be is 100% fog. There we go. Very simple. And that's that. Done. I think we've been done. I am happy with that. So we've got GL position, we've got our colour going through to the fragment vertex, and we now have fog. So whilst we're here, let's have a look at the texture shader. Well, it's the same, isn't it? Nearly. It's going to be nearly the same. Not quite, though. Oh, wait a minute. No, put you back. Put you back. position, texture coordinates, of course. Line 5 becomes the same. The layout. Alright, I didn't get that right, why not? Okay, paste. Oh, I did get it right. Z. So that's line 5. And we're going to have the next 3 lines. Copy to replace that line. Lovely. Of course, that upsets this thing. Goodbye. That's going to become a capital. So I am now capitalizing everything. Properly. So model view projection, yeah, okay. It's exactly the same. I'm trying to think. Not very easy to think. I think when I need you. Copy. This is uniforms, isn't it? So yeah, we'll pop you with the uniforms there. May as well have you two. Let's have. May as well do both with fog. Now going out, we have surface, 2 light, 2 camera, and visit. Yeah, we just don't have the color. Instead, we have texture coordinates. Fantastic, that will work. Okay, I'm happy so far. That's going to be the same. GL position doesn't change. The calculation for it doesn't change, should I say. Alright, let's see what I've done wrong. That's now a vec 4. Okay. Delta camera is still the same. Lovely. And all of these are all the same. There is no difference whatsoever in the way the calculations work. The only difference between a texture and a colour is what we pass through here. So that's the only line that's different. There. And of course, that affects that. There. And of course, we have to pass in location 1, either the texture coordinates or the colour. Which is why you were seeing me split the code between does it have textures, the has textures boolean, saved our bacon all the way through. And that's that one done. That was quick. Right, so that's our vertices done. I'm going to keep this open. And we'll have the frag. You. Yeah, we're up to 2 files now. Okay. Alright. So the fragment shader. Now the fun starts. Now the fun really starts, because this is where that GL frag colour ain't going to be equal to V colour no more. Well, it is, but in a completely different way. Ah, dear. It's going to be fun. First of all, let's get our variables right, shall we? That's going to be the key to this one. So, in vec4 colour is basically that lot there, isn't it? So we can copy those over. Like that. What is it on here? Is it Control-Alt-Shift or something stupid? No. Alt? No, Control. No. How do I get a block going? Control-Shift. No. Alt-Shift. Yes. Finally. I knew it had to be one of the two. In. Alright. V colour. Yeah, that's okay. Just change you to a capital C. For a second. What's this? Open log file. Oh, P off. I'm not opening no log files. Not really that bothered. Telephone's going downstairs. Do they not know I can't get downstairs in time to answer it? And I've got no missed calls on my mobile. YouTube's just said hello. Okay, what's for dinner? Don't know, I've just had them all delivered this morning, so I don't know yet. They delivered coffee though, I do know that. Whoa, that was lovely. Okay, let's get some real calculation stuff going, shall we? This is where it gets complicated. The final answer is definitely not going to be what we've got there. I'm just wondering how we're going to make provision for a skybox. We can make provision for a skybox. No. Well, what I'm going to do is I'm going to use a sky colour as the fog colour. That might be a good idea. Could do it that way. So what do we need to know? We're going to need to know a few things, actually. We're going to need to know some uniforms. You see, you can have uniforms in here as well. Uniform. Vec3, I think. Yeah, we'll try it with the Vec3 anyway and see how that works out. Light colour. What happens if you've got neon lighting? Spelt the American way. Light colour. Uniform. Float we'll have. Let's have shine. God, have I not used shine dampers yet? We'll need it. Shine damper is how shiny the surface is for the light, how reflective it is. If you use the shine damper variable can create mirrors and reflections. So to go with that, that's the damping of it. So if we're going to use a shine damper, we'll also need to know its reflectivity. And all of these can be gotten from the OBJ files. I'll have to find them. Or we can control them ourselves. Reflectivity. Is that a word? I don't know. It is now. I've just made it up. Oh gosh. I don't. Wouldn't be a blades. I've got another blades issue. So yeah, I'm going to use a sky colour as the colour of the fog. So if it's night time, the fog will be darker. If it's daytime, the fog will be that kind of grey shininess that it is, or whiteness it is in during the day. That kind of thing. So it got some kind of control over it. The colour of the fog. Right. We're going to have to work out some units. I've got everything in from here. Yeah, we're happy with that. Right, you can go. Right. To make our calculations easier, we are going to use unit normalization on our vectors. That makes each vector equal to 1. And when put into calculations, it's easy to divide by 1 or multiply by 1. So it makes our calculations a lot more simpler because it takes away half the calculation, basically. So we're going to do that. So we're going to have a vec3, and we're going to have our unit normal. Now normally you would send in your normals already normalized, but in case you don't, we're going to do it anyway. So normalize is, believe it or not, given to us free of charge. It's quicker to do it here. It's hard coded into the chip. That's going to be our surface normal. That's simple enough. So that's our first one. We're going to have to normalize the light vector as well, aren't we? So vec3 unit light vector equals normalize, and that's v underscore. Which one is it? To light vector. That one. Yeah, I'm happy with that. Who else will we need to do? The camera, of course. So there's the three main ones, which is the normal, the light vector, and the camera vector. Those are the main ones. So vec3. That gives us our angles of reflection and stuff. Unit vector. To camera, is it? Yeah, unit camera vector, we'll call it then. Well, no, it isn't. It's been reversed now, so it's vector 2. Vector 2 camera from the object. We did reverse it before we sent it, so we'll normalize that. And that is v underscore 2 camera vector here. We'll have that one. Alright. And now let's start the Phong lighting equation. Alright, so the first part of Phong lighting is ambient. So, ambient. Now, there's two ways of doing this. We can pass it in or we can make it up. Because all it is the background light. And there should always be some. If you're in a dark room at night, there's always ambient light, even if it's only from the moon coming through the window. Something like that. There's always a little bit of light coming from somewhere. Nobody knows where. Hey ho. Right, ambient light. How do we do ambient light? So let's make some ambient light. Let's do a Vex 3. Oh, Muppet, will you stop doing that? Alright, just call it ambient light. There we go. So our ambient light equals whatever we want it to, really. I'm going to make it up. I don't think there's any point in passing this in. This could be a constant. Really? That's a thought. That'd speed it up, but it doesn't really matter. Choose a low number. Obviously of lighting. Somewhere between 1% and 5% of lighting. So I'm going to go with, I want a bit of amber, don't I? So I'll go with 0.5% red. I'm making this up, don't worry. I'm going to go with 2% of green. And I'll go with 1% blue. That might be interesting. Won't be much, but you do need something. I mean, absolutely, you need something. Just run this. If you have a look at the moment, you can see the ambient light, and then I put the blue up. But the background here would be considered the ambient light. As you can see, the model itself isn't lit. So, yeah, it's going to look a little bit different by the time we're finished with this. It should look nice, actually. I'm hoping. Right, that's the ambient light. We've done that. Diffuse light. This is the main light. This is the main light that bounces around and scatters around the room and hits the object and bounces off objects and stuff like that. So diffuse lighting is the real McCoy. This is the biggie. And this is fun. So call this direct light from a source. Lamp, sun, jet engines, whatever you want. It's a light source. And this is going to be fun. It's really difficult to do. So what we do is we take a float and we decide on the light intensity. How's about that? Is that okay? Float light intensity looks okay to me. And what it is something called a DOT, dot. The dot product of, and you'll have to look this up unless you want me to explain it. If you want me to explain it, I will do so, but I won't do it in this video. I'll do it as a separate video. I'm quite happy to do that. So we're going to take the dot product of the unit light vector against the unit normal. So that angle. There we go. So the angle between the normal and the light. And remember, the normal is at 90 degrees to the face. So it comes down. Imagine unit light vector is the face. So the light will come from the source. It'll come down and bounce. It's straight up is the normal. So it's from the normal to the light. That's the angle using the dot product. We know that now. It's a percentage, by the way. A dot product. I think it, yes, it returns a percentage, not an angle. Percentage of light in this case. So now we've got a percentage of light using the dot product. What can we do with it? Well, we can say that the diffuse light is equal to the light intensity, which we've just decided, the percentage, times the underscore light color. So if it's the sun, the light color will probably be 0.9, or 111. I usually try and make it a bit yellowish, so I'll probably go 0.9, 0.9, 0.8. Take a bit of blue off. But that's it. That's your diffuse light. Now comes the real hard bit. And this is specular. Specular light. And this comes bouncing back at you. This is the reflected light, direct from light source. So there could be more than one, I suppose, direct from light source. This will not cause glare effects on lenses, on glass. So that glare effect you get off when you're trying to take a picture through your camera, it won't produce that. What it will do is it will produce like bright sparkles on the surface, like you would see on water or on a car. You'll see that glint, the glint of light. That's what this will produce. That's wrong. It's how much light is directly reflected to the camera. I think that's a better way of putting it. So this is actually a little bit awkward because we need to know the reflected light direction. And we have to calculate that. And we're going to call it reflected light direction. Why not? May as well call it something that it is. And that's going to be equal to, oh, I do love these graphics card, reflect. Thank you. It's a function that's given on the graphics card. So we want to reverse a direction. It's a reflection. We want the reverse direction of the unit light vector. That's right, because we have to do it backwards. Minus unit light vector, and it'll be reflected upon, or it will be reflected from the unit normal. Unit, because this gives a percentage again. Normal. It's got cosine or sine, no, cosines in it. Right, so that will do that calculation for us. That makes it a lot easier, doesn't it? I like it when things are done for us. That's rather nice. The next part is, well, I'm just going to call it specular. I'll call it, it's a factor. Specular factor. How much, how can I put it? This is how much of the light will reflect into the camera or your eye to cause the specular highlight, that glint. How much of that glint is there? Is it very bright or is it very slight? We need a percentage again. So we'll use a dot product to give us that because it has a cosine in it. And it's the reflected light. So it's a reflected light direction. And the unit vector to camera. How much comes back down that unit vector? Unit vector to camera, that one, please. So how much comes back down our line of sight? That's your specular factor. That's neat to explain. He says, not knowingly. What's the next one? On the list, the damping. We have to include the damping, don't we? So we better put that in. The surface might damp the amount of specular factor might be affected by damping. So we need to damp it. So we have a damped factor, which equals roughness of the surface, I suppose. It'll be a power. Yes, I don't want this as a linear. I want this calculation to be to the power of. So it isn't, the roughness of a surface does not give a linear reflection. It gives a scatter. So it's a power of rather than linear. If you know the difference, a linear graph goes like bottom left to top right, where a to the power of graph goes along and then goes steeply up. So the rougher the surface, the less light we're going to get, basically. So the more steeply up, the zeroer. So it's percentages. The more zero we're going to get. So specular factor, unless we do it the wrong way around, and then it'll be more. If the rougher it gets, the more it reflects. Now we'll know if we get it wrong. Trust me, you will know. So damped factor is your specular factor. Yeah. Specular factor, that's that one. To the power of how much we are damping. And we've put that in already as the shine damper. You gave ourselves that as a uniform up here on line 10. Okay, I think we're ready to calculate the specular light. Yeah, we've got enough information. All we needed to know was how much was being reflected. That's all we needed to really know. So as you can see, we took our reflected light, we decided how much we were going to see of it, and then we damped it down from a damper. Roughness of surface, you can call it. Reflectivity of the substance has got nothing to do with the roughness of surface. Water is very reflective but can still have a shine damper. Yeah, okay. Is it? Reflectivity. What's that called in physics? Like a prism effect. There is a word for it. So low values would be cloth. So cloth equals low. Metallicness would be medium to high. And water, glass, high. Gloth? What's gloth? Let's call it gloth. Low equals smooth. Okay, I think that's a good way of putting it. Not sure. Right, let's get this specular light worked out. What we're going to call it? Let's call it, how's about specular light? That might be a good name to call it. Equals. Yikes, stamped factor. Yeah, we'll need that. So we'll pop you in. We're going to multiply you by the reflectivity. What else can we multiply you by? So we have used everything now, haven't we? Shine damper was there. Reflectivity is here. Unit normals and stuff like that. Yeah, that's correct. So the only other thing we've got here, again, is the light colour. That's it. It's a straight calculation. It's a straight multiplication. Oh, we're getting close to a frag colour now. Can you feel it? Can you feel it gonna come in and blast us away? Because here it comes. Right. Because of all of these calculations, the values could go outside of the 0 to 100% range that we want to use. So let's have a final lighting value. No, let's just have a final. Thank you. Has anybody asked me to explain anything yet? No, good. Final lighting. I'm going to call it a VEC4 because I want it to be a VEC4. I'm going to call it lighting. As simple as that. And it's going to equal a VEC4, which is then going to open a bracket. And we're going to clamp. That's the function we're given. Stop it going out of range. So specular light, we'll do that first. Specular light. We're going to clamp that between 0.01% can be the lowest, and 10% can be the highest. No, in a brightly lit room it wouldn't. It'd be 1. Alright. Where will that put us? Here. So plus. No, put plus at the end of there. It's going to look better if I do it that way around. Plus. And that's going to be clamp. Open brackets. Diffuse. Light. Comma. I think I'll use the same values. Helps if you make them float. Do not make them doubles, otherwise it will slow, the whole process will slow down, grind to a halt. The processors are better at 32-bit and can do them a lot faster than 64. We'll do that. And again, we'll clamp the last value, which will be ambient light. This isn't right. Something's nagging me about this being wrong, but it'll do to start off with, because all we're doing is adding them together. Why don't we just add them all together then and clamp the result? That's a good question. That's a question I really have to ask myself, and I have to ask myself right now. I think I've got that the wrong way round. Right. We now have to mix it all up to get a frag colour. So all of the colours have to be mixed in now. And we can do that quite easily using a mixer, which is, again, given to us. There you go. We've got a mixer. And this will take vec4s. So we'll need a vec4 for this bit. Vec4. So u_sky color. We'll mix that color. About that. That just means it's at 100%. Rather than in the shade, you could have that as that's how you get your shadows, by the way. Let's have a comma because we need another one. Lighting. We'll have a mixture of mixing lighting. Time b. Whoa. v_color. Which is the item we sent in. We started with glFragColor equals v_color. That's where that goes. And there's a comma. And I think we're going to need some more. What can we put in the visibility? Yeah, we haven't used that yet. Visibility factor. That'll do. So we've got our V colour, our visibility, and our sky colour. Fantastic. That's it. That's the calculations. How it's done. If you want this explaining better, it would take me a while and I'd need a pen and a pad set up on the machine, which I can do, and I would draw it all out for you and show you the diagrams and everything, and it all looked nice, honestly. But that, folks, is how you do the Phong lighting. And by doing it in the fragment shader and not in the vertex shader, where a lot of people do it, you don't get something called faceting. You look up faceting, light faceting on 3D models, you will see that it looks awful. Well, it doesn't look awful, it could be useful as an effect. So you could make a facet colour and a facet texture and put all of these calculations into the vertex shader and then just pass out lighting. Yeah, just pass the lighting value through, sky colour and the visibility, and just put the mixer at the end. So you could do it that way and you would get a faceting shader. It's perfectly up to you how you wish to do things. It isn't. I do not ever say what I'm doing is correct. I don't like that final lighting equation at all. I know that I don't like it because I hesitated. So I'm looking at it very carefully now. If you clamp specular light and then add a clamp and then add a clamp, you can still go over 1.0. So there's a problem there. And if you do go over 1.0, what happens? Nothing, really, I suppose. We'll just go to 1.0 and it'll ignore any value above and just treat it as 1.0. But there's a multiplication at the bottom. Lighting times V colour. So we're not expecting it to go over 1. I'm thinking that we should clamp the lighting. That's better. That's what I've got in my head. That's what it says in my head right now. Maybe we should clamp the final lighting value. Do we need to? I don't think we do. Will it affect much? Will it affect anything? No, I don't think clamping it, putting the extra calculation in, would actually affect the outcome. Or it would make it darker. The outcome would become darker. Because colour can be saturated. So without the clamp, we would probably get saturation. We could get to saturation, I think. Maybe that's what we want. Let me just put some notes in. because if I don't, I'll forget. And then I'll probably change it without even thinking. Or leave to get a color saturation. I don't know how to spell saturation. It's S. Saturation. I.e. blinding light. Is that an effect that we want to generate? It could be a side effect of what we've just programmed. These are the things you have to think about with lighting. Not just will it work on the object that we put the light on, but how will it work on the object that we put the light on? And that's why I find this interesting to program, why I studied it, because I was very interested in the different effects that you can make, like the fog, including the fog effect. What I've done is I put a very minimal fog effect on it, so it can't. I don't think it'll interrupt, or you'll be able to see it that much. But we could try turning it up. It could also become a variable. You could have variable fog. Yeah. Alright, we've done texture. Bert. Yeah, you're... Okay. Pop you over here. Yes, that was interesting, that aspect. Let's get the texture frag up. Alright, so we've got all of these outs. Now we can have you. And now I know how to do this, I should be able to do it. Alt-Shift. There we go. The reason I do it this way, by the way, is because these two have to match. The outs must match the ins. It's case sensitive and it will be a major point of errors. GL frag color equals texture. Well, that'll stay the same. Texture, right, give that a big T. There we go. Just get rid of the error for a minute. And we'll leave you alone for a minute or two. Texture sampler 2D. Might need more than that. Ah, dear. Let's see what we're going to need. That's an interesting. There's something I haven't mentioned. What happens if a texture doesn't load? We could check for it. No. Let's not. Let's live dangerously. Have we got a sampler? Yes, we have. Texture sampler. Okay. Want some more uniforms, don't I? Okay. Let's put the thong frag over here now. Think about it. Alright, so visibility. Yeah, I'll take all 4. I want to do these 2 the same. Right. Well, that's the same. Oh. Ambient light's the same. Otherwise it'll look weird. If it ain't the same, then it will definitely look weird. I think this is all the same. I'm just going to be honest with you. Yeah, all the lighting is going to be the same. Absolutely. Because we don't use sampler or the texture coordinates. Who are we going to be? Where are we going to be using our sampler? Sorted, so it's going to stay the same, this. All we need is you lot. So it's exactly the same. There's no reason to change the calculations. None whatsoever. There's the calculations. They're all the same. And then at the end, we'll do that. Why not? Done. I'm happy. Yeah. That's the only change I'm going to make. So instead of doing a mix of colours, all we do is take the lighting and and multiply it by the texture that we've got. That's a lot easier. Hell of a lot easier. I like that. Textures are easy. Colours are not. You don't have the sky colour. Do we use the sky colour anywhere else? So I'm just looking at the calculation here. Sky colour and visibility. So I could make it a mixture. I am tempted to leave it just as that for now. Because it's the same equation. It's just this mix at the end. Yeah. I'm very tempted to throw that in. I don't think we're using the sky colour at all. We are not. That goes into our fog. Visibility. Yes, we haven't got the fog in here. That's what's missing. Right. I'm gonna have to change this. Sky colour is only used here. Light colour is used there. Got it. Got it. It is a mix. Damn, this is a complex one. Alrighty, so if I were to do that, split the lines down so it makes it easy for me to damn well see it. Alright, right, I need that mix. As you can see, lighting times V colour. V colour is what we pass in. But we want a texture there. Right. Now you'll see why I did it. So I can see it all. So our drag colour, lighting times texture, is that line there. Yeah. So our lighting times texture goes 2 lines down. Goes up. 1, 2. 1, 2. Down. 1, 2. There we go. And that becomes a thingy. Right. So we start with mix. And then we open a bracket. We then ask for a vec4 of u underscore sky color. That one. Comma 1.f. You could blend it in a bit better than 1.0 if you might just take half or something. Not sure. Comma. Comma. And v underscore visibility. And that'll put the fog in. Fantastic. That's it. That's the final command. Yeah. Both of them now say the same thing. And due to that, I'm happy. It may crash like nobody's business, that one. It'll be interesting to find out. Alright, so that's your GLSL done. Problem is, our code doesn't use that, does it? Look, no lighting. Yay! Our code still uses the basic shaders. To use our new super duper improved shaders, we've got to rewrite the shader code. And the shader code is in here. Yeah, it's got nothing to do with the shaders now. It's all to do with our static library and how it handles our shaders. And we'll find it under shaders. Here. Our API may have to change. Shader program, yeah, everything's going to be alright there. Yeah, we have set this up for a win. It is looking okay, but can we improve on that? This is going to now be the question. Can we improve on that? Yes, we can. Do we need to? No, this is Qt. We don't need to, do we? Find attributes and get all. I think we can do this straight as a change. How are we going to render? We were sending our model matrix. There's your model matrix. Int block. Uniform location. I see. and shader set uniform value. These three values. We would have to locate it each time, wouldn't we? That's inefficient. That is very inefficient. Right. Okay. That's too inefficient for me. I don't like that. Let's have a look then at color shader.h. Let's not do that. Let's simplify all of this. Okay. No, don't like this at all. Let's call that yeah, model matrix location and set it to a value. We're not setting these to any values. That does mean we're going to need a view mat matrix location. And we're going to need projection. Mat location. Just put them all equal to -1, I think. That's going to be the easiest starting point, isn't it? Now we need the others. This is color shader. Don't need that open. Just pop you up here. Light position might be a good idea. So I'll have int m underscore light position LOC location plus -1. Putting everything to -1. We've got more than that, haven't we? We've got the uniform for light position, but then we've got the fragment shader. With these uniforms here. Alright, let's put those in as well then. Let's keep those as well. This will make it easier. Light color. Yeah, light color location. Even though it's in the fragment shader, we've still got to keep track of it, I think. It's easier to keep track of it all at the start and get it saved in to our color shader class. Keep it there and then effectively use it properly. Because we can send one command with all the information and just load everything up to the graphics card straight off. That would be a lot better. Shine damper. Yeah, int. Just call it damper. No, don't like that. Call it what it is. Shine damper. Stop abbreviating. I don't know. What's the next one? Reflectivity. Yes, reflectivity. Right, so I've given them a value, so we don't need to set them up as much. That should be good. Right. When we set up our color shader, something interesting here. Uninitialized, always initialize a member variable. It is initialized. M_lock MVP matrix. No, it isn't. Because I just took it out. So that doesn't exist. We could make this into load uniforms. Couldn't we? Right. Let's see what we've got. Got two choices. That can change. Load uniform values. Because then what we would have is our MVP. Model matrix, comma, and Q matrix. You can see why I like writing downwards now, because I can have two things side by side quite easily and still carry on. Model matrix, view matrix. Like that. Why does it always put 4x4 right at the bottom? Model view projection. And we can do the rest of them as well, can't we? So, light position. Yes, we can do that. What is our light going to be? It's going to be an entity. We don't even have the entity light, do we? Hold on a minute. I want to put light position in. We don't have a light entity. Alright. So if we don't have a light entity, it's going to be hard to do it, isn't it? Where can we have a light? What would a light entity look like? This is where an ECS system would do a lot better than what I'm about to do, I think. At some point, we would need to do that. We could just make something up. Yes, we could. You see, a light is just a position and a colour. Am I going to cheat or am I going to do it properly? I'm going to do it properly. Header. Light.h. Add. Get to you in a minute. Am I really going to make it a class? Yes, I am. Because later on when I do an ECS system, I'll need it as a class. So yeah, we will have a light source. light.cpp. No. Today's date is 30th of April. Wow. So let's pop you on there then. Been doing well with this, haven't we? It's in entities. Ooh, just one sec. Namespace. Amber 3D, is it? Yes, it is. And what folder are we in? Namespace. We are in the folder of entities. And that'll do. Well, oh, I've got Dingling. Hello, Dingling. I'll get to you in a minute, phone. That's it. That's what I want. Light CPP V hash include light dot h. A light. We'll have a class. Light. And it will hold two variables. It will have a Q vector 3D position. We better include a Q vector D. There we go. And we'll have a Q vector 3D. What should we have here? Color? Yeah, why not? And then all we need now is a light. Explicit light. And that's going to be a Q vector. This is such a simple class, it's ridiculous. Position. And a Q. And a Q. One space back. Vector. 3D color. That's it. And it's done spacing for me. That's the whole class. Wow. Right, let's set that up then. There's no destructor for it, so that's fine. Why can't I set this up? Yeah, we're just developing that, so that's okay. Save that one. Or is it because of the way I've written it? Probably. Fine. Yeah, that's right. It can't do it. Oh, Visual Studio, you're so special. It couldn't do that for me. M_position equals position. M_color will equal color. I don't like that being there. And that's the only function it's going to have. It's a storage class. There's nothing special in there. So everything else can be done in light.h. And we can just pop them all here. So set void set position. I'll just write them all there because it's easier. To Q vector 3D position, so that we can change the position of our. What's wrong with it? Just ignore it. M_position position. Go. That's valid. I don't know what the heck it's giving me all these things for. Set color. I want to be able to do a sunset if nobody else does. Vector 3D color. I don't know why Visual Studio doesn't do this for you automatically, but it doesn't. Well, not that I know of anyway. Anybody can say differently, then that's fine. I'm always willing to change that idea. Why is it not happy with M position and M color? Pardon? Yeah, I'm outside the class. Q vector. Now I've done this on purpose without any stars. Get position. So you get copies. Is that wise? Well, it doesn't matter. It's only a couple of very small variables. Return position. It's a very, very small storage class. Yeah, it's not going to be used much. Possibly once. Get color. So I'm not really too bothered about it being immaculately brilliant. I'm just going to punch in the basics. That can be altered later if anybody really wants to do so. Personally, it's a storage class. That's the least you could do. In fact, it should be a struct. And then I could just get rid of that. Nah, I'll do. Right, so we can now have a light. All right. Where are we? All right. Entities, light. And that's just so that I can do the next line, which would be light. And light, I suppose. Shine, damp, and reflectivity. I think they're just floats. I think they're just going to be... Alrighty. Right, so we've got light. Okay. Float, damper, comma, float, reflectivity. Have we covered everything there? Light, light colour. Yeah, that comes with the light. So position and colour come with the light. Damper and reflectivity can come in separately. We've got everything. We have everything that we will need. Thank you. $42. There. Good. Has been altered by this. You guys. Come out here for a wander, will ya? Let's list you out properly. A nice big load of uniform values. Well done. Alright. So, how do we do this? We go... What do we have? Let's have a look properly. What's wrong with light? We're in the wrong area. Right, so we're in Amber 3D. So that's going to be entities. There you go. That's where it is. There we go. That's fixed. That's done. That's done. Hello, Muppet. How you doing? We now have the ability to load all of this lot. So how do we load it? We've got the location. Ouch. Get all uniform locations. Here we go. We haven't finished this lot. Right. We've got to get them all. Let's do that first. So, copy you over. And these have to be exact. otherwise it won't work. And we're doing color shader. These have to be literally exact. So this is where copy and paste is allowed, to make sure you get exact copies of what you're doing. And we're going to need 3 of them. So we will have model, view, and projection. And that will be model, view, projection. Projection. Do it properly. There we go. Alright. So we've got the first 3. That's good. There's another one here, so we'll take that one next. This one is called... Don't need you anymore. This one is called... that one there. Oh, wait a minute. Why do that? Why not just do that? And you are light position. Thank you. We'll have you next. Yeah, it is this simple, unfortunately. Then we have the fragment shape. 3 more. 4 more. Yeah, 4 more. I want sky color as well. Copy. One, 2, 3, 4. Do it. Should be all we need. Projection, light position. Next one is next one is light color lock. We've got one missing. So we've got light color lock, shine damper. See. What happened to our sky color? We'll add it. Sky color look. Just add it. In the fragment shader. light colour. Doesn't matter what you use in the final program, as long as you get all of this information out of the shader at the beginning. Very quick to do, and you don't have to do it again. So it's only done once. And it just stores it for future use, basically. It also means we don't have sky colour being passed in. Okay. That's okay then. Pass it in as a QVector 3D sky color. Call it. Why not? Seems like a sensible name. Done. I prefer separations on. Hash include Q vector 3D. There we go. Sorted. Oh, colour shader's looking a bit more robust. So what do we do when we get all this information? We send that information off. So when this is called, it sends whatever information is given to the correct location. That's the idea. How did we do it before? The question. Close you down slightly. Oh no, it's not in here. It's in here. Let me just do a quick look through here. So we used shader, which is a QOpenGL shader program, which is its own ID. Set uniform value. We use that there. Oh, thank you, Muppet. You're just lying right across me. That's really nice. So shader isn't shader. It's going to be get ID, isn't it? Yeah. So this will be get ID. No, program ID. So we've already done that. Right, I think I'm nearly at the stage where we can do this. Then it would not be that, would it? Copy. Be that. And then it wouldn't be that. It would be the value sent in, which is model matrix. Like that. And that should work. And it's not doing so. Is it get program ID we gave it? Start, stop. Where's get program ID? Oh God. Sure we had it. Where is program ID? Where's program ID itself? Why can't I get it? It's there. Oh, it's come up now, has it? It was just being lazy. Yeah, I thought that was right. Set uniform value, there we go. Alright, so do that 3 times. Another 2 times, should I say. 1, 2. That will be that one. Goes in there. Yeah, this is a little bit simple, programming wise anyway, because of the way we set it up. This is going to make it so easy. It's ridiculous. The VAO will give us all of the data that we need, but these will give us all the uniform values that we need. And it's going to make it model view. It's going to make it very, very simple to utilize in the renderer, because this is about to chop out a dirt great big of the renderer and replace it with load uniform values as just a straightforward instruction, which is amazing, really. As in how much this is going to do for the renderer is rather good. How many more do we need? 1, 2, 3, 4, 5, 6. 1. Yeah, we'll take it from 1. 6 of them. 2, 3. No, there isn't. 1, 2, 3, 4, 5. Right. 3, 4, 5. We'll see if we can match all of these up anyway. Model a view a projection. After that comes a light position. That one. And that is that one. So it's v dot get position. Right, I'll do that. I got the address, didn't I? Okay, what's wrong with this? Expression must have a pointer type. Alright, then it is dot, then you derp. Stop derping me around. What's wrong with get position? Is inaccessible. What the hell are you talking about? Of course it's inaccessible because I'm stupid. Oi, light, H. You do something for us. You make it public. Nope. Oh, don't. Sorry, my bad. That is a big sorry, my bad as well. I should know better. View projection light. Get position. Then we need its colour. That's light dot get colour. There you go. That's that one. Next, shine damper. Light colour. Shine damper. Where are you? Damper. Okay. Next, reflectivity. Reflectivity. Good stuff. Good stuff, this. This is how to be accurate in copy and paste. Copy and paste errors are a big problem, by the way, and you should never do what I'm doing now. You should always type it in. But unfortunately, my typing sucks due to the fact I don't have a left hand that works properly. So we'll pop in the sky colour as well, why not? How's about that? So they've all got the right things now. They're all going to hopefully do the right thing. That's your uniform values all set. The variable values are all set by the vertex array object. So we literally have everything. That's automatic, by the way. This process here, get all uniform locations, is automatic on loading the correct shader program, which is now not basic color. And this one is going to be called Fong color, I think I called it. Yeah, Fong color. There we go. That's done. That's all there is to it. That's all we needed to change. Qt's done it for us. Does everything for us. Worst thing is, because of the way we've programmed the shaders, both shaders are exactly the same. Think about it. So if I do, the only thing you've got to do that's extra in the texture shader is the texture. And that's not a uniform value. Wow. We have mastered the shader program. Don't need to touch that part. Or we could put all of this into that part. No, because this is for Fong shaders only. Okay. So we want color shader.h, texture shader.h, color shader.h, please. Feel free. What did we do here? Yeah, that's the same. Set it out properly, why not? Model view projection, light, shine, reflectivity, sky Colour. Yeah, we'll have the lot. Exactly the same. Because I made them exactly the same on purpose, really. I'll be honest. It was to make this bit easier. And that replaces that. Okay. So that's you two done. Just get rid of you. List this down. It's working out quite well, this. We could cut down on the number of variables required quite easily by making struct out of all of this. Because I think that's what you would do. I mean, that would make more sense than just pass the structure over. Alright, that's cleared that up. Right, okay. Right, so I don't need you anymore. Color shader CPP. Would you like to just cross there, please? Kill. Start at the bottom. It's exactly the same. And this is where a copy paste error could occur. Yeah, I did include that last brace. That was my bad there. Everybody happy in here? Looks like it. Yep, braces match up. Yep, good. I didn't make that error after all. And now I just got to fill this in. So, fill that in. So, line 45. To there. You there. V. Done. Backspace 1. That's it. Done. So our shaders will now load the correct ones. Is it Fong capital T for texture? I hope so. How have I spelt these things? Yeah. Make sure this one's spelled right as well. Yeah. Okay, that's broken our program totally now. Lovely. We have shaders. We now need to do a test. How shall we test that? We need to test it with what we've got rather than what we're going to have. So I can't test it from here. RPG dev cannot change. Interesting. So to run a test, we have to do the test on the renderer itself. So create model. model matrix, view matrix. We don't need this line. We don't need this at all. We don't need to set the uniform value in here at all. So it replaces all of that. Alright, so the replacement will be shader. I'm going to have to invent some values here now. Set uniform value. What do we call that? No. Texture shader. Load uniform values. We do still have. Oh, of course, yes. Sorry. My bad. Bad thoughts. Shader. Load. Oh, God, have I done that? Yeah. Doing. It is shader, isn't it? Oh no, did we just pass the ID in? Yes, we did. We only passed the ID in, not the shader. So this only has nothing in it. Oh no! Damn you. Hash include. Ho hum. Let's do a few of these. Amber 3D slash API. Shaders. Just in a texture shader to start off with. So that texture shader has to be passed in. API colon texture shader. Oops. Right. So now it's a texture shader. I can do it. Shader. Get program ID. Yeah, whatever. Alright, render has gone wonky. I've just put something in the wrong place. There. What? Why did it just change it to that? Huh? Got ya. Still, no, this isn't working. I know why it isn't working. Right. Because I wanted that one. That works now, but I put the stupid include in here. Thank you, Muppet. She snuzzled all over me. Oh, bless. We'll pop you in. That means we don't need that. That can go. Lovely. Renderer, looking happy there. Don't need that. Lovely. Still got red blobs at the bottom. What's going on? Textured model. Get model. Textured mind. Why? What's wrong with textured model now? I just messed it up here. No. What's wrong with it? Model, textured model. Yeah, we get it from the entity. Textured entity. What's going on? There's something weird going on here. Buggered something up that I shouldn't have done. Right. Textured entity. Yeah, that's right. Is it just having one of its wobblers? Oh no, that one's wrong. Program C. Give it a pointer or something. I don't know. Give it anything. That's okay. Draw elements is fine. What's wrong with my textured model here? Oh. Thank you. Right. We're ready to start now. So yeah, it should be shader. Load uniform values as plural, open brackets, and then it's that lot. Right. So model matrix, we've got that. That one. Comma. Next, view matrix, we've got that. We're doing good here. We've got some of these. Next one, projection matrix. We should have that as well. Fantastic. Next. Light. We're going to need that, aren't we? Alright. M_I. There you go. Go and make a light. Renderer. And it is in entities. We do have a light. M_LIGHT. Make it a star. Actually, no, considering what it is, don't bother. Let's, yeah, go on. We'll do it properly. Star. It's just a storage class, for God's sake. Do we have a light entity? Camera. Hash blurred. We have now. Lovely. There's our light. Fantastic. So now we have a light. We need to make one. Where shall we put it? Above to the right, I suppose, of the, yeah, above right. Above and right. M_light is a new entity light. Open brackets, it's explicit, so it should only give me two options, which it does. And that's going to be Q vector 3D, open brackets. And I want to place it up. So X, we can put a minus 5. Upwards plus 0.5. No, 5.0. So 5.0 F. In and out. I'll put it out of the screen as well. Just put it all as that. That'll do. Comma. And you want a Q vector color. Okay. Vector 3D. Color, I'm going to just put to 0.8. 0.8. 0.8. Only wants a 3D one. Fine. That'll do nicely. We've got a light. So, back down here, we can get on with it. M-light. Which one did it want first? Position was. Get position. Comma. What did it want next? No, it just wanted the light itself. The address. Oh, well, that's fine. It's easy to do. You can just have it. They are all yours, mate. Star. Thank you. That's why I didn't want to make it a star, because I knew it would bug it up that bit. Damper. It's a float. Alright, 0.1 F. I don't know. Reflectivity. It's a float. 0.5 F. Oh, again, no idea. Sky color, Q vector 3D. We will give that sky color 0.8 F, comma, blue, really, isn't it? RGB. Yeah, it goes R up, doesn't it? Yeah, I remember now. It is 0.7 F, comma, 0.8 F, comma, 0.75. And I've really messed that up, haven't I? Right. Let's go with that. Anybody want anything else? No? Okay. Put semicolon in, and we should be happy. Right, so I've made up a few values there. That'll use our shader. Everything else remains the same, except we don't have the normals. Yeah. Muppet. Can't think of anything else I'd want to put in this lot. Texture shader. No, there's not really much I want to put in that lot. Entities, no. Trying to think. It will be in the other part of the API, won't it? How's about float start normals, comma, int num normals, comma. How's about that? Yeah, that might work. Where do we put them? In 3. Yeah, I think that's the only change we need to make there. That's the only change we need to make there. Right, textures are going in non-texture coordinates. 2, yeah, why is it going in 1? Oh? Store to attribute list, store to attribute list. Alright, well, text coords and colors are going in 1. Positions are going in 0. So we must be going in 2. Yep, we are. Just copy the positions one, which is 4, 2. Location 3's on that, yeah. Not positions anywhere. Normals, normal. No, normals. And num. That's that bit done. Very easy. That'll put it on the graphics card in the correct slot. It's 2. We decided layout 2. We did have something else. We had a layout in on the frag. No, we didn't. For all uniforms. That's fantastic. I got a reference sheet for that. Oh right, yeah, you can put the color into me. Yeah, I remember. You can put layout location equals 0. Out vec4 color. I got no, that's wrong. No, not doing that. Right, so now we've changed the GFX loader that has a knock-on effect. That's that done. That has a knock-on effect on how we use it. In dev, under source, platform, no, core. It's got an error in it. Come on, give us an error, thank you. I can find it easy. There. End text shader, get program ID. What's wrong with that bit? It's in the renderer. Right. So that's altered. That's good. That was annoying me. Alright, so we're sending through Cambria, blah blah. Yeah, that's okay. But we should have another error up here somewhere. No, we don't, because it's not in this file, is it? It's in load amber model. Now have an error. Oh, save. Load amber model is back up to the top. This should be okay. But this won't be. We've got a raw model error here somewhere. There it is, raw model loader. Okay. That'll help it out. That gets rid of that error. That's it. I can't think of anything else. Alright, let's fix... let's just take a slow down on the brain for a second or two. Because I might have forgotten something. And knowing me, I have. Because I'm Blades, and I can forget things very easily. Like, I've already forgotten what we did at the start of the video. So I've got no chance of knowing whether I've missed anything at all. I've got no chance at all. We've altered all the shaders. Let's go down the pipeline. We've altered... Actually, I can ask it, can't I, what we've altered? That's obvious. We've altered GFX loader, load Amberskies model to match, correct. The shaders, color shader and text shader have been altered. We could move that over to a central location, I think, but it's shader dependent. We've added light, interestingly, because you have to. If you're going to have lighting effects, you have to add a light. Do we have to enable lighting? That was in OpenGL1, where you had to actually enable it. Hello, Pudding. I don't think we have to in GL3. I think it does it. It only defaults to the pre-lit thing if you don't put a light in there. The light itself doesn't have to be added. In OpenGL1, the light itself would have to be added into the renderer. Into the shader, sorry, as a light. We're only allowed 8 lights, I think. I think we're now allowed 64, 32 or no, we're allowed 32 still. But you can, how can you put it? You can instance them, so it's not as bad as it sounds. You have 32 different modelings of light at any one time. That's 32 channels. So obviously what we've done is very, very simplistic. Right, let's try and debug on... Let's see, who shall we debug first? You. I want to clean. Alright. Build it. See what it does. I've got no hope of this working first time, by the way. Well, according to Microsoft, that code is fine. Absolutely fine. Thank you, Microsoft. You're very helpful. So you couldn't find any errors in my code? Sorry, I don't believe you. I'm not that good a programmer. I've just asked it to check my program properly. Please do it properly at Microsoft, and don't cut any corners this time. Thank you. Alright, raw model's having a problem with a Q vector and a Q string. Does it give me a line number? And this I do want to look at. If constant, yeah. So raw model CPP is having a problem with the Q vector Q string. It told me. And it's this texture file name that's upsetting it. Yeah, okay. Let's have a look how we're using it. Are we setting it up here? We are. Q string isn't a star. Right. Gotcha. Damn. Yeah, I've already noted it. Don't like it. You see, what we're doing at the start is putting null into this texture file name. So when it's coming, because this is a vector of Q strings, so it's trying to initialize it to nothing, the 0 page address. And you can't do that with a Q string. Well, you can, but you're not supposed to, but you're supposed to treat it like a string, not a Q string at that point. It confuses the compiler. Otherwise, I think we've used it correctly. That's the only one that came up, was it? Alright. Type Q string, yeah. It's a constant. Yes, I know it's a constant expression. Oh god, it means you have to delete the first one. Right. That has to be a null pointer. It needs to have something in it. We don't set it in here. Awkward. See, when we're doing this here, we just do a pushback. We don't say set texture file name, and which one. For which texture. You can't do that. I said null, didn't I? Try null pointer then. That's the official one. QString is a pointer. It is not. It's a constant. It's still going to give me the same error. Doesn't matter how I try to initialize this, it's going to give me that same damned error. It's not an error though. Yeah. What it's telling me is it's a bad way of doing it. But we want multiple textures. Yeah. Constants compiling, source file, blah blah blah, yeah. And that's on 36, a GFX loader. Oh, yeah, I know what that is. Alright, GFX loader. 36. That's correct. And yes, it is constant expression. Yeah, we could put const in there. Oh god, now I've got to search through all of these for mine. Great. All of these are in the header files that I'm using because of the way I'm using them. Alright. I think we're okay. I'll try with that. Alright, just build it. Okay. Now let's clean our main one. Let's build. We're not too bothered about the first one, we want to know about the second one. He's going to crash. I can't see a way of it working. 66, 94, any bigger? 96. Alright, we haven't altered anything on function keys 1 and 2. Function key 3 has nothing in it. Do you know why it's got nothing in it? I expected that, but hey ho. Do you know why? I know why. I've got no doubts about why. Yeah. That's awesome. We got it right. Fantastic. So yeah, the shaders are right. Woo! Ish. There is something I do want. No, I don't. I need to figure out the values that work now, don't I? Okay. Now, do I leave this as a debugging project for you people? Or do you want to see me debug it? If you want to see me debug it, mention it in the note, whatever it is, below. Not the chat thing, the replies and stuff. Comments, that's it. Put it in the comments below. I'm going to give you this to have a look at. Now, I know what's going on, so to me it's not a problem. But see if you know, if you can find out why nothing shows up on screen. An interesting one. An interesting one to do. Okay. So that is full shader. No. I'll put first try at full shader upgrade to Fong lighting. Code compiles, but does not display the model. Got a damn good idea why now. Needs debugging. to correct this. There you go. There it is. Alright. By the way, the code is correct. Don't try and find the error in the code. Well, actually, no, the code may not be correct in one area. What's doing it? Okay, you got it all. It's all on GitHub now. So, here we go, GitHub. So, www.amberskies.org.uk is the way I get to my own GitHub code because it's easier for me. There's a button on there. And here's the code. So in RPG dev, you will, oh gosh, get off. In resources, you will now see that we have our Fong color and fraggy thingies with all of the Fong lighting in and everything. All the code is there that I typed in today. But that will not place the model on screen. Interesting. Go grab it, have a look at it, see if you can work it out. It's quite simple, just chuck it in and have a look at it through any kind of text editor and see if you can work it out. I'm absolutely gobsmacked that it worked. First time. I was really thinking I'd missed something. I don't think I have. Wow. That's awesome. Everything looks okay. And there's no... If you follow it through from the beginning, you'll come to this part here. Needs checking. Keystring model to load color shade color load to GFX. Amber models, load the model from the .amber model file in. There we go, Amber file, reads it. Reads it. If has normals, reads it. So the normals are there. Or are they? Has textures, reads it, else. Yep, has textures, puts a texture in. Else puts texture coordinates in. No, sorry, puts the color in. Colors. The raw model becomes a null pointer. Yeah. Load. Set the set the shaders. That's right. And then we get the raw model with indices, vertices, normals, colors, and textures. So indices, positions, vertices, yeah. Normals, colors, and textures. They're all going in the right order. Load a texture, texture file name. That shouldn't be there. That's wrong. That's missing Load texture file now. Oh no, we get the... Damn it, no, that's correct. No, it's not. That's one of the errors that's coming through. Remember, it's from this textures business. So if, and it's telling us try an if statement. I think this is where the if statement should go. If raw model that's it. That's the only thing I think I changed there. That gets a model texture. Well, we don't want a model texture for... yeah, we don't want texture. Oh, we have M has textures. Of course. Have we encountered that anywhere else? Ah, okay. That's where M has textures gets set. Does it? I don't know. I'll have to look at the code properly. Interesting. Very, very interesting. You better not work now. Thank you. Dreading that then for a second. I thought, whoa, don't you dare work. Which is good. This is what I want you to see, because this is going to make us understand OpenGL a little bit better, I hope. Because we now need to look at OpenGL properly. And I know the model's there. I know that it's rotating, because I can see up in the top left-hand corner the FPS is correct. So I know it's there. I don't need it to. I don't need to see it to know. Yeah, there you go. So there's your homework. Anything else that's coming on the computer here? Need to tell you about? Oh yes, I'm live on YouTube. Thank you. I want you to all take care out there. I want you to stay safe, and we will be going through the debugging process on Saturday. And we'll see if we can get this thing to work. Remember, this is going to be live. You're going to see me do this live. So you may come up with a different solution. If you do, pop in on Saturday and tell me. Come and chat. Chat about it. See if you can come up with the same solutions. Ta-da! I love it. I love it when a plan comes together. Take care. Stay safe. And I hope you get some entertainment sometime. Alright. Bye for now.